Alright guys, today we're working on correct number 7 and 8. I'm going to do number 8 first, because if we do number 8 first, it's going to give us some pointers to do number 7. So we're given some equations. We're asking which of these points maximizes the objection function, which is, it looks like our objective function in terms of the sentence is this immediate thing that follows. So for an x and a y, it's 3x plus 4y. So if we have a series of x's and y's, we're looking to maximize this stuff based on this information. So I don't know what this is all about, but I know that I can plug x's into an equation and I can plug y into an equation and see which one is the maximum value. So let's do that. So 3 times my 0 is from the x, plus 4 times my y value, 3 times my x value, plus 4 times my y value, 3 times my x value, plus 4 times my y value, 3 times my x value, plus 4 times my y value. And then we just have to simplify each of these. Okay, so 0 times anything is 0, plus 0 gives us 0. 3 times anything is 0, plus 4 times 6 is 24. 3 times 4 is 12, plus 0 is 12. And 3 times 5 is 15, plus 4. 4 times 1 is 4, which is 19. So the maximum value here is B. That one's pretty quick. Only took us about a minute and a half, as long as we knew that we could just plug points into this equation. So here's the problem with number 7, and here's why I did number 8 first. Number 7 doesn't give us points. It says what's the maximum value of the function when we're given this thing. And so it looks like we're given equations. So if I were to solve each of these and put them in slope-intercept form, when if y is greater than or equal to, let's see, subtract 4x on both sides, and to cancel it over here, give me minus 4x plus 12. And then this other one, I've got a little more work to do. So it looks like I have to subtract 4x on both sides again. We get negative 4x plus 24. Make sure you pay attention to your inequality direction. And then my last step, oh my goodness, excuse me, divide by 3. So we're divide by 3 everywhere. We get y is less than or equal to negative 4/3 x plus 24 divided by 3 is 8. Okay, so we've got a y equals and a y equals. Let's maybe graph this thing. So I'm going to give myself a pretty big old graph space. I need to go up 12 for this one. I need to go up 8 for this one. So let's just count my 4s. 12, 8, 4, of course 0. So let's graph this one first. So we go up 12. We have a slope. Remember, slope is rise over run when we have mx plus b form. So slope is rise over run. So rise of down 4, run of 1. So I'm going to go down 4 and over 1. Down 4 and over 1 again, and down 4 and over 1 more time. And then I'm going to make this line. Looks like we are graphing above this line, so I'm just going to put arrows going up. Second one, we're starting at up 8, and instead of going down 4 and over 1, we're going down 4 and over 3. So down 4 and over 3. 4, 5, 6, we can get some more. Down 4 and over 3. And we draw this line. It looks like we are shading which way? Y is less than, so below this line. And then these last two are kind of confusing. We want all the x's that are bigger than 0, so we only want these numbers. So we want only those numbers. And we want all the y's that are bigger than 0, so we only want these numbers. So we want only the numbers that are in this area. There's a wonderful taste of that. Alright, so my name got hollered from the hallway. You're welcome. Okay, so we've got 3 points we got to check here. So they gave us points in this last one. We've got 3, 0, we've got 6, 0, and we've got whatever this point is over here where they cross, which we can set these equal to each other. So negative 4/3 x plus 8 equal to negative 4x plus 12 to figure out what they're actually equal to. And I would use a calculator to help you out with this. Because I am going to add 4x on both sides and minus 8 on both sides. So I'm going to get positive 4 over here. I'm going to use 4 minus 4/3. This is going to give us 2 and 2/3, which is going to be 8/3 total. So I'm going to multiply by 3 to get rid of that, and eventually divide by 8. So that's going to cancel, that's going to cancel. We get x equals 4 times 3 is 12, divided by 8 is 1.5. That gives us 1.5 for this point, comma. We can use either of these other points, the x's, to figure this other part out. We have an x, we need to find a y, so let's plug 1.5 in. So negative 4 times 1.5 is negative 6 plus 12, gives us positive 6 for this one. Again, I just did negative 4 times 1.5 and then I added 12 to give me this value. Okay, so I need to plug each of these 3 points, so 1.56 into this one, 3, 0 into this one, and 6, 0. So I noticed that with 3, 0, 2 times 3 is going to give us 6, plus of course 3 times 0 is going to give us 0, so we get 6. 6, 0 is 2 times 6 plus of course 0, which gives us 12. So we're going to do 2 times my objective, so 2 times the x, plus 3 times my y, which is going to give us 21. So again, this comes from just plugging it in exactly like we did down here, but we had to find the x's and y's for this one. So here's the moral of this story when I'm looking at this. I'm looking at about 4.5 minutes for this top problem, 4 minutes, or about 1.5 minutes for this bottom problem. Honestly, if this is one of the problems that you're seeing on the EOC, I would just 100% just like, alright, let's guess on this problem because it's not worth our time to spend it on this. So yes, we can, but guess. Do this easy one. It's just asking you to plug stuff in. Giving you x's and y's, you got to plug in for x's and y's. You have to realize there's x's and y's. But this, oh my gosh, so much to do at one time. So part of our test taking is going to be, let's go figure out which of these problems we can do kind of quickly, figure them out. And then the other ones are like, man, just like take your time and guess on this. This could greatly speed up if you had a calculator because you could plug this equation in and this equation in and tell it to calculate this point, and then you could just use a little bit of algebra to do these things just like you did down here. But it's not worth your time. At this point, this is one of those where I would say, okay, our time is better spent elsewhere. Let's guess in this problem.